What if, instead of driving to your friend's house, you took a road trip straight up?
Like the road just curves upward and keeps climbing, past the clouds, through the sky, higher and higher until you reach the edge of space. Today on Seriously Dave, we're doing just that, exploring all the Earth's atmosphere has to offer until it's gone. So buckle up and grab some snacks because this is gonna be a crazy ride.
Seriously Dave!
Our adventure begins in the Troposphere, the layer where we all live, breathe, and complain about the weather.
All weather happens here. Rain, snow, thunderstorms, and even the occasional, why is it hailing at 85 degrees outside? And we breathe a mixture of gases, mostly nitrogen, but a little bit of oxygen mixed in there. Plenty to keep us alive and healthy. Now let's get on the road. As we start to go into the sky, you're gonna notice two things happen. One, the air is going to get really thin, and two, it's going to get cold. As we go up, the temperature drops about 3.5 degrees Fahrenheit for every 1,000 feet we go up in the sky.
We've arrived at our first stop, the top of the Troposphere, about 6 to 7 miles above Earth.
And here we need to watch out for commercial airplanes because this is where they fly. And I hope you packed warm clothes because the temperature outside at this point is negative 80 degrees. And we're already above 80% of the atmosphere, so there's hardly any air to breathe up here. Can somebody get me some oxygen? Human beings can't survive outside, which makes me wonder.
That's Mount Everest, just a few thousand feet below us. It's covered in mountain climbers, but there's not enough air to even survive. How do they... Oh, that's how they do it. And I'm curious, if we were to shrink the Earth down and its atmosphere to be the size of this globe, how high do you think the atmosphere would go above the surface before it was totally gone? Stay tuned for the answer.
Now, at this point you might be asking, if warm air rises, why isn't the temperature hotter higher up in the atmosphere?
Well, first, sunlight heats up the Earth's surface all day long, and up in the atmosphere, you are further away from that heat source. And the second reason is because air spreads out when there's less of it up in the atmosphere. It's like this aerosol can. When the air comes out, the can gets really cold because the air was at a high pressure, and then suddenly it's spread out and at a very low pressure. To spread out, the air uses its own heat or thermal energy, so it cools down a lot. It's called adiabatic cooling if you want to get all sciencey about it.
But there's good news if you don't like cold weather, because things are about to heat up. Soon after we get back on the road, the temperature rises once again to about 32 degrees, which, hey, let's face it, that's a lot better than negative 80.
Because of this reverse and how the temperature is changing, this part of the atmosphere was given a new name by scientists. Welcome to the Stratosphere. The big attraction here and our next stop is the ozone layer. It's not much to look at, but I'd argue it's one of the most important parts of our atmospheric road trip. And here's why. Ozone absorbs most ultraviolet radiation from the sun, but still some gets through and gives us sunburns, but you can think of the ozone as Earth's sunblock.
Well, without the ozone layer, we'd have to live underground in caves to avoid constant, terrible sunburns. That would stink. And here's a fun fact. Ozone is toxic to human lungs and a pollutant here at the surface of the Earth, but up in the atmosphere, it's Earth's savior and the only reason that life can live on the surface of the planet.
You can imagine these Skittles are UV radiation, and I'm the ozone layer, gathering the UV and getting energy as I do, which is why the stratosphere gets warmer. And now it's time for a quick scientist shout out. In 1985, 3 British scientists discovered that a hole in the ozone layer had formed over Antarctica. Super alarming, I know. Later confirmed by NASA satellites, thanks NASA, the next step was figuring out where that hole came from. Enter Mario Molina of Mexico City and Sherwood Rowland of Delaware, Ohio, who figured out that chlorofluorocarbons, also known as CFCs, were behind this Earth-endangering hole. They were used in aerosol cans and refrigerants, and they were really bad stuff. Eventually banned from being used, the ozone hole is now slowly healing.
You're going to want to grab your coats once again because we're about to enter the Mesosphere, the coldest layer of Earth's atmosphere. Here, the temperature gets down to negative 100 degrees Fahrenheit. I'm staying in the car this time.
And really, there's almost no air here. We're now above 99.9% of Earth's atmosphere.
And you'll notice something weird if you get out of the car. There's no sound, because sound requires air for sound waves to travel through.
It's more like space, but there is enough air for one super cool thing. This is where meteors burn up as they approach Earth. In other words, this is where shooting stars shine, because they interact with the little air there is, and there's a lot of friction as they plow through it, generating lots of heat and light.
Now let's get back on the road and continue. As we leave the mesosphere, we near one of the last layers of Earth's atmosphere, the thermosphere.
Here, things heat up once again, all the way up to 4,500 degrees Fahrenheit.
Seriously, can we just call this space and go home? No, I'm kidding. I really like it here. We're about 50 to 60 miles above the Earth's surface now, and we're about to see one of my favorite things.
Because this is where you find the auroras. And let's face it, there isn't much better than this, especially when you view it from the edge of space.
And at this point, here in the thermosphere, we've finally reached the edge of space. Sort of. Not everybody agrees on where space starts.
But here it's 62 miles above the Earth, and 1 hour into our road trip, we've reached the Karman line. Above it, planes can no longer fly because there isn't enough air to give them lift. You need to travel in rockets from this point. This is generally considered the edge of space. And to answer my question from before about how far the atmosphere would extend above this globe, the Karman line, or edge of space, would be 2 pennies above the surface. That's it. That's all there is between us and the void of space.
But there is no manual for Earth. It's up to us to figure this all out. And as you may have seen, humans kind of have trouble agreeing on pretty much anything. To prove my point, this is the edge of space, but somehow there is one more layer.
The final layer of Earth's atmosphere, even though there's really nowhere left, is the exosphere. Here you'll find satellites and the space station, but really not much else. The way I see it, airplanes flying way up in the sky are really at the end of our atmosphere. Sure, there's more air above them and a few different layers, but not much. So I'm gonna do what I can to take care of my air. And if you like this road trip and wanted to keep going all the way to the moon, well, that'll be another 3,854 hours until you get there. I'll be at home breathing fresh air. Until next time, stay curious.